To understand why Sakana Fugu is different, we first need to understand how most AI models normally work. Traditional AI systems like GPT or Claude usually rely on one primary model to process your request from beginning to end. Everything, from reasoning to coding and writing, is handled by that same model. Sakana Fugu takes a completely different approach. Instead of asking one model to do everything, it creates a team of specialized AI experts. Each expert focuses on a different part of the problem before everything is combined into one final response. The moment you submit a prompt, Fugu begins analyzing exactly what kind of task you're asking it to solve. If it's mostly coding, it may prioritize coding specialists. If it's research, different expert models may become involved. All of this happens automatically, without you ever seeing the complexity behind the scenes. Think of Sakana Fugu as an AI project manager, rather than a traditional AI model. It decides which expert should handle each part of your request. Then it verifies, combines, and optimizes the results before sending you the final answer. Sakana AI actually released 2 different versions of this orchestration system. The standard version is designed for everyday work, offering faster responses and lower operating costs. Fugu Ultra is built for difficult problems that require deeper reasoning and more extensive collaboration between expert AI agents. Both versions use the same orchestration philosophy, but Ultra allocates significantly more computing effort to complex requests. That means Ultra may involve more expert agents, more verification steps, and more internal collaboration before producing an answer. The trade-off is that higher quality often comes with increased processing time and potentially higher operating costs. Here's one of the biggest misconceptions about Sakana Fugu. Fugu is not one giant frontier language model competing directly with GPT or Claude. Instead, it's an intelligent orchestration system designed to coordinate multiple powerful models as efficiently as possible. This architecture also provides an important advantage: flexibility. If one provider becomes unavailable, the orchestration system can potentially rely on other available expert models. That makes the overall system more resilient than depending entirely on a single AI provider. Now that you understand how Sakana Fugu works, it's time to answer the biggest question of all. Does this architecture actually outperform today's leading AI models in real benchmarks and practical use? Now let's look at the benchmark results that made Sakana Fugu one of the biggest AI stories of the year. Sakana AI evaluated Fugu across several demanding benchmark suites covering coding, reasoning, scientific knowledge, and software engineering. Remember, many of these numbers were reported by Sakana AI, while broader independent testing is still developing. Let's begin with coding performance, where Fugu attracted the most attention. According to Sakana AI, Fugu Ultra achieved exceptionally strong live code bench performance, outperforming several leading models on this benchmark. That immediately caught developers' attention, because coding remains one of the toughest areas for modern AI. But great coding benchmarks don't automatically guarantee better software development. Building production software requires planning, debugging, testing, architecture, and consistency across many iterations. That's why experienced developers always combine benchmark results with real-world testing. The next benchmark focuses on graduate-level scientific reasoning. Fugu and Fugu Ultra reportedly achieved one of the highest GPQA diamond scores in the comparison. This suggests the orchestration system can perform extremely well when solving complex scientific questions. Another important benchmark evaluates real software engineering tasks rather than isolated coding questions. Here, Fugu Ultra also demonstrated highly competitive performance compared with several frontier AI systems. These results indicate that multi-agent collaboration may help tackle larger engineering workflows. Across multiple benchmark categories, Sakana Fugu consistently remained among today's strongest AI systems. However, benchmark leadership varied depending on the specific evaluation being measured. In some benchmarks, Fugu led the field, while in others, competing frontier models still maintained an advantage. So how does this compare with the AI models many people already use every day? GPT 5.5 remains one of the strongest all-around assistants. Claude continues to excel in long-form reasoning. Gemini offers deep integration across Google's ecosystem. Fugu's biggest advantage isn't necessarily replacing those models. It's intelligently coordinating multiple expert systems behind one interface. Now that you understand how Sakana Fugu works, it's time to answer the biggest question of all. Does this architecture actually outperform today's leading AI models in real benchmarks and practical use?